welcome back to the channel. My name is Chima, and today I'll be solving Leetcode problem 102, binary tree level order traversal. So before I start, I just want to say I was able to fix my audio issues, so from now on, all my videos I shouldn't really have any problems with the audio. So I hope that solved um, any issues that other people might have had on my previous videos. But let's get straight to the problem. So for this problem, here we're given the root of a binary tree, and the goal is to return the level ordered traversal of its nodes values, i.e. from left to right, level by level. So basically what we're trying to do here is we want to go level by level through our tree and basically return the level ordered traversal of its nodes value, meaning that as we go level by level, we want to keep track of all the nodes that we visited um, on each level and store that in an output. So in this first example here, we're given this tree, and the result is going to be um, 3 on the first level, nodes 9 and 20 on the second level, and nodes 15 and 7 on the third level. And that's what you see here. On the first level, we have node 3. On the second level, we have nodes 9 and 20. And on the third level, we have nodes 15 and 7. So that's basically what we're trying to do here. So this problem is just simple breadth first search, where we're just going to traverse our tree and append the nodes that we visit on each level. So that's what we're trying to do here. In terms of our breadth first search algorithm, how we're going to implement it is we're going to have a queue to store the nodes of each level that we're on. We're also going to have an auxiliary array to keep track of our complete output here. And as we go through the tree, we're going to append the current level or the nodes of the current level that we're on to the front of the queue or to the back of the queue. And as we pop from the front of the queue, that's when we're going to be updating our output array. So another key thing to note about the way that I'm going to solve this is going to use a slight trick where every time I append to my queue, I'm going to be keeping track of the current level that I'm on. That way, I know which specific level I need to be appending the current nodes that I'm visiting on in regards to my output. So yeah, let's get to the solution. So for this question here, I use a deck to make things a little bit easier. To my deck, I'm going to start off by adding my roots and the first level. So in terms of trees, we refer to the first level as being level 0, the second level being as level 1. So that's why I have 0 here. Then I'm going to say here my levels are going to be an empty array. And an edge case that we want to check here is that if we weren't given any nodes, or basically if we're given an empty tree, we basically just want to return an output of an empty array. So I'm going to say here if not roots, return empty array. That means that if we don't have any roots to traverse, just return an empty array with no levels. So that's what it means. And we're going to kick off BFS here by saying, well, we have elements in our queue to traverse. We're going to pop the current node and also pop the current level from our queue. That way we know which nodes to append to our levels array. Current level, or rather current node and current level equals queue.pop left. And yeah, so once we do this, there's a slight check that we need to do here. So in our levels array, as you can see in this output, it's actually a 2D array, or an m by n array, where each index represents the nodes of that specific level, right? So in this input, we know that on the first level, there's only one node here. On the second level, there are 2 nodes, etc., etc. And as we're keeping track of the level that we're on in our queue, we can just check if our levels array needs to have another array within it that represents the current level that we're on. So how do we do that? We can do that with a nifty trick by just checking the length of our levels array and the current level that we're on. And if the current level that we're on is less than, or rather, if the length of our level array is less than or equal to the current level that we're on, then we know that we need to add an extra level to our levels array. So if length of levels is less than or equal to current level, then level is the append empty array. And after we're done with that, so our levels array, the current level that we're on, we want to append the current node value. Current node value. Alright, so then here is the bread and butter for BFS. We need to just append the children to the queue and continue to iterate through this loop until we've explored all the nodes in our queue. So to do that, just check if the current node has a left child. If it does, it's our queue. I'm going to append a tuple where we append the left child and then we append the next level. Right, because if it has a left child, that's basically we're going down a level. Same thing goes with the right child. So I'll be repeating pretty much exactly the same code for the right child. And then once we're done with this, all we need to do is return the levels, and I believe this should work perfectly. So let's just run through the code really quick just to clarify what we're doing here. So here we're just popping current node and the current level from our queue for processing. Here, checking if we need another level to be added to our output to represent the current node that we're on. We're appending the value of the current node that we're on to its corresponding level. And here, last but not least, we're just adding left and right children. Left and right children to our queue to continue traversing tree in BFS fashion. Then, yeah, so let's run this code and see how it works. So what I've done wrong here is on line 32, rather than node, I actually named this current node, so I have to change that over here. Same thing with my right. And run it again. And this passes all 3 test cases. Let's submit it. And this works and it runs pretty well. So let's explore the time and space complexity here. So for the time complexity, we know that we're going to be iterating through every single node in our tree. So in worst case, we're going to iterate through n nodes. So for our time complexity, we can say that that's O of n. For our space complexity, we have auxiliary data structure here levels that's going to store every single node that we process. So also is going to be O of n. And that's about it for this question. If you still continue to have any queries about this question, don't hesitate to leave a comment down below. I'll be quick to respond. And yeah, hit the like, hit the subscribe button, and have a good day. Thank you.